Hello, I'm JW. This time we're going to be assembling the Autotransformer. Now this video is the long version and this covers pretty much all of it in fairly extensive detail, hence the extreme length of this particular video. Now there is a short version of this which has also been posted up at the same time, so if you want to see that one then that's fine, it's the same content, it's just this particular video has a lot more stuff in it, covers things in a lot more detail, so it's really not much point watching both, just one or the other, depending on whether you want just the sort of summarised version or the one with all the detail. Now this one's the one with all the detail, and we're going to be fitting it into the same case that it came with, but it has been repainted, and we're also going to be making a new front panel for the thing, fitting various items into that front panel, and of course wiring up all the stuff inside and all of that. So let's get on with it. Now I'll start with just having a look at the components we've got here. So of course the transformer itself over here, this is the case which I have repainted. It's a metallic colour, and it's called gunmetal, which is basically grey metallic there, steely dark industrial metallic it says. So there's that. So I've already painted these off, so we're not going to be showing that in either of the versions of this video. So I have some wire here. This is for the internal wiring, and this is where the mains flex will go in. And we've got some of these things here. Now this one is a voltmeter, and we can see that it just goes 0 to 500. Two terminals on the back, and then we've also got some other ones as well. Here's another voltmeter, and again this goes 0 to 500, so the idea here is one is for the input, one is for the output, and then we've actually got two of these which show the current, and those go 0 to 10, and again they're direct connection, no external components needed. Those came from China. This is the original handle which went on the top, so that will be going back in that position. The front panel, as we see on this bit here, has a massive gaping hole in it, so we're going to be actually covering this whole thing over with a new panel that's going to be made out of this stuff here. This is aluminium composite, or also known as dye bond and various other names. I have shown this in a previous video, but we'll be basically cutting a piece out of this with various holes and things as appropriate. And then that will just go over the whole front of the panel here. Rubber feet here which will go on the bottom. Two handles, so these are actually on the front here on either side, so when we put the things in the middle it won't get bashed in by things obviously from the front there, so just sort of protection purposes. New mains plug for the lead. Panel mounting socket, this one's made by MK, so that will go in the front as well. And we have a neon indicator here, this is orange one. This is actually made by Arc Electric, which was the same make as the old one that was in there. I actually have two of those, not sure whether we use both or not. And for changing the actual tappings on the transformer without having to open it, we have this delightful switch, and it's a 4-position switch, so 1, 2, 3, 4, which gives us 4 tapping options from the outside without having to open up the case. And this is a very small switch, as you can see. Had to get one of this size because when that transformer is in the case, there's not actually a whole load of space inside, so this happens to be the one which will fit. Still have enough clearance behind to get that fitted in there. And that's pretty much all the components we've got here. The only other thing is a piece of flex for the actual mains lead, which costs, we'll just get some appropriate one for that. That will go in the back via that thing, and then say the transformer itself, and there'll be various bolts and things to fix all of this stuff together. Now this is the cable gland we're going to use, just a nylon one. It's grey, it's an M20, so it needs to fit through a 20mm hole. So that just goes inside, that goes on the top there. Now we're going to use the original hole here on the back of the case for the cable entry, so a perfectly reasonable position there, so no problem there. But the problem is that this thing is too big to fit in it, so if we put the nut there, and see it's considerably bigger than the hole, so we need to enlarge this hole to 20mm using a 20mm hole saw. Now here's the hole saw we're going to be using, it's a 20mm job, so obviously no surprise there. Now a problem with these things is that the centre normally goes into the metal, and that's what holds it in position whilst you're drilling the outer hole. But of course we've already got a hole here, so if we were to use this and attempt to drill, what we'd find is it would chatter all over the place and therefore be extremely difficult to install there. Now another option of course is to clamp this down really securely onto the drill table, and then theoretically the outer should stay in one place, but even that's a bit dodgy and dubious. So what we're actually going to do instead of that is to get two pieces of timber here. These are just some scrap bits from something else. This one is short enough that we can actually clamp it underneath here, so we'll go like that, so a nice clean bit of timber there, and then we'll clamp this other piece underneath, and then we're actually going to clamp the whole of this to the drill table And then when we take our hole cutter here, it will actually bite into the timber, which will basically keep it in one position, avoid it sort of shattering about. And then of course we can just enlarge the hole to a suitable size. And you can also use this, say with a handheld drill if you were sort of drilling something, so you didn't have a drill press available. And so it basically centres this in the hole, keeps it in place. So what we've got then is the two clamps here holding the two pieces of wood underneath onto the metal. We've got the vice underneath there, which is clamped onto the pieces of wood and also the edge of the metal there. And we've got it lined up so that the hole will of course go down through there. So that's basically the theory. So let's just get that drilled out. This is steel, I believe. It's not sort of hugely thick, but we'll go fairly easily through it, as you only to sort of snag there. So that's gone fairly well. See the hole there obviously, and it's to use that sort of timber piece to keep it fairly straight in the middle. There's a bit of wobble there, but not a critical size dimension. It's just provided that the thing actually goes through it. So just get all this out of here and cleaned up, and we'll have a look at what we've got. Now there's the hole we just cut, so we'll just remove any burrs from the edge of that. And of course on the other side as well. So that seems reasonable there. So and then of course this thing will just fit through there, so that will just go in here like that, and then the nut of course goes on the back to secure it in position. Now this hole is bare metal, so what we're going to do is just put a bit of paint on that. I've actually got some left in the can. Here's a little bit in the bottom, so just touch up around the hole there, and then we can obviously fit the appropriate item in there. So that was reasonably successful. Not necessarily the best arrangement for doing these things, but nevertheless it's using what we've got to get the solution that's required. Now this is the lid for the actual thing, and this doesn't have anything attached in it at all apart from the handle which came with it. Just goes in the top in there, because it's kind of a wraparound design, so there's nothing we need to actually fix into this. It just has the small holes here to attach it to the other part. So what we're going to do is attach this handle back in here just with the two screws, but of course being a metal case and a mains powered item, we need to actually make sure the case is connected to earth properly, and as I've painted over the whole thing, at the moment that's going to be fairly difficult. Now we could rely on the little holes here, but what we're actually going to do instead is to use one of these fixings here that comes through and actually attach an earthing wire to that, so we have a decent connection with inside the case and not rely on the little tiny screws that just hold the lid on. Now I'm just going to remove some of the paint from here, because of course we need a metal connection there so we get a good fixing down onto the case. And by doing that, it also means that the handle itself is grounded as well, or earthed, so that's pretty likely to be hanging on to, so fairly important there. So what we'll just do is grind some of this away, and we're going to use one of these. This is one of these sort of motorised jobs. It's on a flexible lead here, the motor's hanging up over there. I've got this wire wheel on at the moment. This is pretty much destroyed, but it's going to be good enough just to scratch away a bit of paint there on this one. And of course eye protection is essential. When using these things, those bits will fly off and pretty much get all over the place. So see, they've just cleared away around the edge there, so now I've got bare metal, which of course when the stud goes through, that will actually bite down onto the metal, provide a good electrical connection both to the handle and the case as well. So that's fine then. So what we need to do now is get a wire and make some kind of attachment to that. Now I've got this green wire here. This is single core. Now in terms of actually attaching these, then it's basically the crimp here with the insulated piece, stripped off a small piece at the end of the wire there, and then this will just simply insert into the crimp there. And we can see the wire just slightly peeking out at the end here. And we're going to use these ratchet crimpers here. And as these are colour coded, of course, it's going to be the red one, which is in the centre. These have twin jaws, so it basically crimps over the metal piece where the wire is fixed, and also on the other bit here, which of course is where the insulation goes. So just a question of placing that into the crimping thing, making sure the wire is still peeking through, and then with all that just crimp down with that. And we can see there the two indentations where it's basically crimped that down, and that is now securely attached to the end of it. Now in terms of length, we're going to leave this quite long because at the moment we don't exactly know where we're going to attach it, so if we leave a sensible length on that one, it gives us plenty of choice when it comes to assembling this later. Now just remove the 2 bolts or screws from this. These are the original ones that essentially came with it, so we'll be reusing those. So we'll put in the top one first. So again, that will just go through the hole there. Slightly tight because of the paint, of course, got in there. And then we'll just thread that on so we can at least move it through there. Now this is the other one. Of course, we're going to put the crimping lug over it, and it does actually matter which way around this goes, because if we do it this way, that's sort of the correct way, so then the case will be here, and of course it will just lay flat then against the inside of the casing. If we were going to put it this way, then that's going to be a bit of a fail, because as we tighten it up, of course it would bend this downwards, and then it would leave this sticking up at a rather horrible angle, pretty untidy. So we're going to do it this way round, so then it gives us a flat surface when it's screwed in. So I'll just go in there with the thing on the correct side, and then we'll hopefully get that lined up with the handle on this other side. So go in there, and then of course we'll just tighten them up with this ratchety thing we've got here, so we can actually get them tightened properly. So that's that securely fixed there, and then we'll just have this coming off into the actual earth connection within the casing. And again, we want it fairly long anyhow, because of course we've got to actually make the connection and then put the case on afterwards, so we need a reasonable amount of length there. So that's basically the top piece finished there. So the spray over from the thing where I've wiped it because the paint was so thin. And then that's our finished casing there with the actual handle. I did clean this up because it was a bit spotting of rust there, but cleaned off okay, and we did it previously. So that's actually the top complete, so we'll get rid of that and move on to the next bit. Now these meters came from China, and being from China they were incredibly cheap, just a few dollars each. If you bought them in the UK then they would have been 10 times the amount. And I got these ones because of the sort of retro type of look here, so basically round there with the analog dial or movement there. This plate goes behind, so we'll just see the round part through the front panel. Now these, just going to check these just to make sure that they are in fact what they claim to be on the front, because of course if they weren't, we could end up connecting it and something could blow up. So just going to turn the meter here to resistance, and we're just going to check the resistance of these things. Now these are voltmeters which are designed to connect directly across the supply up to 500 volts, so we would expect that the resistance between these is extremely high. You would hope in the order of mega ohms. So let's just check these. These are actually marked plus and minus, but for AC of course it won't actually matter. However, it may matter in terms of testing. So let's just connect up the minus and the plus, and we should see a fairly high resistance here. So seeing about 2.8 mega ohms. That doesn't seem too bad. Let's just see what it would do in the other direction. Yeah, so it's actually open in the other direction, so there's presumably some diode or something inside to rectify, because obviously although this whole assembly is rated for AC, the meter movement itself of course won't work on AC, it will be DC only, so that's fine for that one. So we'll just put that out of the way. Now this is the other one, it should be exactly the same, so we'll try on the connections here. So negative there, and we get 2.6 mega ohms again, so seems sensible. And in the other direction nothing at all. So that's perfectly fine. That's kind of what you would expect. Modern meters, if you put them in voltage, have about a 10 mega ohm impedance on the input. That's say got about 2 or 3, but still plenty high enough. Also bear in mind that's at DC, so of course AC it may well be somewhat different. Now these ones are the same casing, but these are actually amps, so what we should find on this is the exact opposite. We should find an extremely low resistance between these, as these have to be connected in series with the load, and of course any kind of resistance there would mean they would heat up and set on fire. So these go from 0 to 10 amps, and because these are a moving sort of analog scale, it's sort of more condensed at the two ends, so 2 of course is pretty much down there, but this thing is rated up to 2 kVA, so that's in the region of sort of up to 10 amps or so, so perfectly reasonable. Now again, these are marked plus and minus, but let's just try the proper way round, and we should get extremely low resistance, so 0.6 ohms. Let's check what the leads measure. 0.6 ohms, 0.5. So we're looking in the region of 0.1 ohms. Again, that's perfectly reasonable. Basically, we want it to be as close to 0 as possible. It's the same in the other direction, so again, that's exactly what you'd expect, because of course current flows in both directions on AC. So yeah, these leads we're using are actually in the region of 0.5, and the thing itself is basically 0.5, so it's basically showing us a dead short between the two, which is what we want. This is the other one again, it's just another ammeter, so it should be pretty much the same deal. Yeah, that's sort of 0.6 again, and just try the other way around. Yep, exactly the same. So that's fine, they are at least what they claim to be. Of course there's shouldn't be any problem with it, but obviously it's the same casing, so who knows what somebody could have actually put inside it. Now this is the bottom part of the case, and this was originally the front. We had the neon indicator here, and this was empty, but it presumably had some kind of outlet on here fixed on those screws, presumably the American type outlets for 120 volts, as that's what apparently this was used for. But this is a horrible raggedy hole and we don't want it. I have painted this side, but we're going to have to cut a fair number of other holes in this anyway, so again it's only got basically one fairly thin coat just to cover over with that. Now what we're going to do with this is actually make a whole panel to go on the front of this, which will basically cover pretty much the whole of the front of that. And we're going to make it out of this white dye bond, which is basically aluminium on one side. It's got a plastic core there, which is black, which is the bulk of the thickness, and then there's another aluminium piece on the back. So we're going to cut a piece of this which will fit basically on the front like that, and obviously completely cover all of these old holes and whatever. And then into that we're going to fit these various meters and things and various other items so that it will look fairly presentable. And in order to avoid the meters being damaged and busted if something knocks on the front of it, once we've cut the actual panel here, as well as things going through, we're going to have these actual handles here which will fit onto the front panel at either side, so provide a bit of protection from things knocking into it, say when it's stored on a shelf or whatever. These are unfortunately satin. Ideally they would have been chrome or shiny finish to match the top handle, but I could not find pretty much anywhere that sold these in a chrome finish and of this length as well, because of course we need the length there so that when they go through the case it basically fills the whole distance there. And so the only ones I could find in chrome were either much too short or they were much too long, or in one particular case I found some which were the right length, but they'd actually turned out that these were 19mm diameter, which was huge, so of course no good for this whatsoever. So anyway, matte silver ones it is, so that's what we're going to end up using. Now of course how to cut this panel, well obviously we could just get knives and tools and saws and things out of there, but we're not doing that because we have a CNC machine, so we're just going to design up the panel Fusion 360, and then we're going to cut out the panel on the CNC machine basically in one pass, which will be the holes and also the outer perimeter as well. So basically it's just shove this on the machine, off it goes, and then when it's finished we have our completely finished front panel, and then all we need to do is just transfer the holes in this onto the case we have here, and then we'll just cut those out with whatever tools we can find. Now, so we can obviously make this fit and everything else, we need to make some measurements here, so I'm just going to write these down in this notebook. So first we need to make sure what kind of size we have here. So width-wise we're looking there at 185, and we're doing this in millimeters, and then the height of it obviously is something else we're going to need. So that's actually coming out as 175. So though it looks square, it didn't, so good job we didn't assume that. So that's basically going to be the size of our panel that we wanted. I may make it, say, just a few millimetres smaller to give a nice sort of overlap around the edge. And then we have the question of the other devices here. Now, of course, these things will come with specifications, and the size of these, I think these are 45mm, but we're not going to believe that. We're going to actually measure them, because who knows what can come from particularly foreign parts. So we'll just measure them with this deal here. So we'll just zero that out. Now these are round, so they fit into round holes. So what I've got here, so it's 44.7. So again, that's perfectly fine. So just make a note of those. So 45mm diameter. Now the next thing is this MK socket. Now this is a strange device because this is a very old design. Someone on Patreon commented on this. I did put a link up there to the specification of this, which the drawing for this actually comes from 1959, and it's still the same. The only difference they've made is the logo is slightly different in the middle. So anyway, this is supposed to fit through a 50mm hole, so we should find that this is in that sort of area. So let's just get in onto that. So yeah, 49.1. So again, we're going to want a 50mm hole for that. So again, that's fine. We can certainly believe that. Now the other stuff is these little indicators here. So just have a quick look on the side of that. So that's sort of 9.7. So we're looking at a 10mm hole for the neons there. Now these handles again did have a specification attached to them. Let's just see what sort of hole distances we are talking about on these. 150, which is pretty much what it claimed on the information. So 150mm between the two holes there. These actually come with their own screws, but we'll probably be replacing them because the one it came with were sort of about 2 inches long, which of course far too lengthy for this one. But yeah, 150mm between, so we go from the inner edge to the outer there, then it's pretty much bang on. There's a drawing of the switch, and you see it's a 16.2mm hole apparently, so we'll make that slightly oversized, but again it's not a hugely critical one because it's only so the switch will clear through the hole. Has a little notch at the top to go with it, and panel thickness here is 0.5 to 5, we've got a 2, so of course that's well within the particular range of that. Now this switch we have here is a 4 position one, and it doesn't have a 0, so it's basically 1, 2, 3, 4, and the whole point of this is that what should be the case is that there's a common input on one of the terminals here, and then when it's in the 1, 2 and 3 and 4, that corresponds to 4 different outputs on the switch itself. And it does come with a diagram here. This basically covers a whole load of them, and this is what we have here, the K10D004NCH, and we can see here that basically we've got L1 there coming in, which goes to 2 in that case, and then depending on the position of the switch it's one of the 4 different outputs, so 1, 2, 3, 4. Now although we've got the labelling in the diagram, we'll just check these to make sure we haven't been given the wrong switch or something, or some manufacturing blunder, because of course powering this up with mains connected and shorting out the transformer would be most undesirable. And what we've got then is terminals on both sides, so 3, 4, 7 and 8 there, 2, 1, 6 and 5 on this side. Now according to the information that's provided, the input should be number 2 over here, and that's also commoned up with 2, 4, 6 and 8. So regardless of the position, we should have continuity between 2 and 6. There should also be continuity between 4 and 8, and there should also be continuity between any of those, such as 4 on the back and these on the front, which there is, so that's fine. Now in terms of positioning, we'll select position 1 on the switch here, and according to the information, the output when in position 1 is in fact number 1, so we check between 2 and 1, we should have continuity. We do. If we now move the switch to another position, continuity has gone away, so that's on position 2 now. Position 2 apparently is outputting on number 5, so that should be between here and here, which it is. If we move it around to number 3, that should have gone away, so yeah, and there's still nothing on number 1 obviously. Now position 3 we're now on comes out on number 7, so that'll be on the back. Remembering that 4 is a common, so we should have between the common and 7, which we do. turn around to position number 4, and that should have gone away, which it has. And then the position 4 on the selector corresponds to number 3, so should have continuity between here and 3, which we do. If we turn it back to one of the other positions, yep, that has gone away. So yeah, it's all as described. Not really surprising, it's a reputable manufacturer, and this wasn't a cheap switch either. It actually cost more than the entire transformer itself, so that is absolutely fine. This is the model in Fusion 360. So this is just the 2mm thick panel. I've sized the outside to the correct size that will fit on the front of the metal case. And then we have various holes in the middle here, those large ones for the meters. This will be the socket at the bottom, 2 of the neon indicators and the 2 switches, and then some text to just put there for in and out. So relatively straightforward there. If we have a look in the manufacturing tab there, then we can see what that will look like in here. And if we go to the simulate tab, we can see how the cutting is going to work. So basically it's going to be in 2 tools we're using. The first one is this end mill here, which will just cut out the outer perimeter, and of course the larger round holes. And then on the one after that, if we move forward, then we're going to use a engraving bit. It's not actually as big as it looks there, it's just how it shows there, but essentially that's going to be used to engrave the text, both the in and out there. And then it's just going to mark the position of these other holes, which are fairly small, they're only 4 and 5mm, so just going to mark the position of those, and I'll drill those out separately later on. So 2 tools we're going to be using. So here's a quick look at those 2. They're both 1/8 inch shank there, so fit in the same collet. And so one is just the end mill and the other one is just that very sharp, pointy engraving bit. And what we should end up with is something that looks like this. So let's do the outer sheet. It'll cut the perimeter, cut the various round holes, engrave the 2 texts there, and then just put little dots where the drill holes need to go through. And obviously it's 2mm thick, same as the panel that we have. So here's the panel, and so there was a bit of a problem there. It didn't actually cut deep enough on the first pass, so I adjusted the settings, did another pass, but bizarrely it showed in Fusion as cutting to the bottom, which the edge did, but the middle only just skimmed the surface. So having to set an extra 2mm depth, it went down to the bottom, but bizarrely that showed in Fusion as cutting 2mm below the bottom, so I'm not entirely sure what the problem there was, because say the outside and the middle were done on the same thing, and the outside was fine and the middle wasn't, and it did show as the bottom of the cut rather than the or the bottom of the hole rather than the top. So anyway, some bizarreness there. Anyway, so we've got the holes here, got in and out for the input and the output voltage. The holes on the things here for the screws I didn't drill on the machine, I just basically spotted where they would go. Just drew those on the drill press because they're different sizes. In theory you could have put a drill bit in the machine and done it, but it's just quicker to do it on the drill press in that case because they're just straight through holes. So basically what we've got is these meters will fit in these holes up here. So 4 of those, and the socket of course goes in the bottom in there somewhere. And then for these here we've got those neon indicators which we saw before. Basically for one of these, so one for the input, one for the output. Our switch will go down the bottom corner here, that'll be the little selector dealie which we had previously, and then this one will actually be for a different switch. I didn't show this before, but it's going to be for this toggle switch, which is basically going to be on and off for the output. I have this in a drawer anyway, and it's another arc electric item. This is rated 16 amps, so plenty for that. So that will just come through the front there and secure in that hole. Now what I need to do is to transfer these holes onto this here and then cut out fairly large chunks of this to correspond with these. Now I'm not going to actually do it sort of individual round holes or whatever, I'm just going to mark and then cut out sort of rectangles in the appropriate place. And we can see here that the panel here should fit on here with about a 5mm spacing on all sides, which is pretty much where that would go. So what we're going to do then is just get some of this tape. This is just masking tape, and I'm just going to just stick that over the entire surface. This shouldn't damage the paint because it's designed to peel off after a reasonable amount of time and not cause a huge amount of damage there. So what we're going to do then is just place this on here, and so we want to get it obviously lined up pretty much square as possible. So that seems to be reasonable. What we'll do is just use another bit of tape here on the edge to secure it in place. So that's the various holes and things just have to transfer, so I'll just use a pen and just draw around the various openings. It's got a little hole there already where that massive slashed out bit was before. Now these holes for the screws are slightly oversized, so for example these are M3.5, but these are actually 4mm holes, so there should be plenty of clearance. And again these are about 5mm screws and we've done them 5.5, so again should be enough clearance there to get them in there. In theory it should be exact, but if they're exactly this size then there's a possibility the handles are not perfect or this isn't perfect, and then they'd obviously be quite difficult to get in there, but just slightly oversized is fine. That's actually already a hole anyway, so I don't have to bother with that. Just draw here. Now of course we don't want to cut around exactly, because if we did, this for example had some extra bits here, so of course we need to accommodate for those, so we're going to have to cut out quite a chunk of that. And the same with these things, as in they've got this square bezel which we want to go flat against this panel, so just going to cut sort of rectangles out rather than try and go around that. And we will also draw out the edge of the panel as well, just so we can get an idea where that's going to be, because of course we don't want to be going too far, and therefore the edge will still need to come within the material so it doesn't obviously create a gap around the side. So that's fine there. So that's all marked up there. So for these I'll just cut out this rectangular piece here, so and a similar rectangular piece over there, and then they'll just fit in behind that, so they'll all be flat and basically level on the front. And then for the socket here, we'll just cut out this sort of U-shaped piece. It's going to go pretty close to the edge here, but again there is a couple of millimetres clearance, so it won't also leave a gap there. And for these I'll just sort of cut around in the general area, because again they're just holes that go through. These I'll probably drill out, because these are actually only 10mm, so I'll probably drill those out with something of suitable size. And then the corners will actually just be drilled out to the actual size, which is 5.5mm. And then the reason for that is we can use these handles basically to clamp on the front panel, and then the screw on the back will actually go against the metal and then secure the panel from all four corners, rather than it just relying on glue or whatever we're going to fix the rest of it on with. So it'll be clamped in securely at four corners, and then the middle of course will just be supported by the metal that's left, which is going to be a sort of a tab here and there. This is how the panel will look. So I've got the 4 meters here. I've cut the holes so they are as tight as possible on those, so they do fit, but so there's no actual gap around those, and so we'll glue those in later. Socket in the middle, 2 screws to fix it, and then the other 2 holes here, one is for this switch here, which just drops in, and then the other one I can have this toggle switch here as an on and off switch there for the power, so that comes through from the back like that. And then we've got the 2 neons there for the basic inputs, voltage and current, and then the output voltage and current there, so these will illuminate when the appropriate things are on. And the idea is to have this one be illuminated when the thing is actually plugged into the power supply. This one will turn off when you actually operate the switch here, and also you plug in whatever the load is in the front, select the various voltage tappings with the switch over there. Now we're going to actually just screw this socket in here, because this can actually go straight in now. These things will glue in a bit later, so just remove those from the panel, and again these will just drop through, screw in once we've got the metal piece on the back. And this socket, say, it just fits through the 50mm, or basically a 2-inch hole there. The screws go into the actual socket itself, just holding it on the back of the panel there. So we can actually tighten those up. So that's now secured there, and we'll put the screws so that they are vertical. So here's the case. I've just cut out the front there, and the paint is just over the top there, still slightly soft, so be a bit careful with it. But essentially this was the old hole where that neon was, so that will be covered up with the new panel. And then all of these will just match up with these holes here, and then the 2 neons will go through these 2 holes on the back, so we'll have that metal tab secured on the back of the centre there. And then the 4 holes in the corner are for these, where those handles will go. And of course this will just sit over the top, approximately like that. And we'll have our meter things go through those, and then the handles will screw in from the back, and will basically sit on something like that. Now we need to put the switch in next, and the actual control here, the actuator goes in from the front, just fits in like that. Now the hole is the right size, but there is a piece that we need to actually add on. That's a round hole, but have a look on the switch here, and then on the top there's that little peg there, which needs to go in a corresponding notch in the front panel. It's basically there to stop the thing twisting around. So just need to cut a little bit there. I'll just use a knife just to nibble away the top piece there, then we can get the switch fitted in. So I've just nibbled a suitable notch there, and then this of course will fit on there, and then the thing will line up. Then it's actually flush all the way around, whereas if it was obviously on there it would sort of stick out in a rather annoying fashion. And it's supposed to be there so it doesn't rotate, although it's going to be tightened up pretty well on the back anyhow, so it shouldn't be a major problem. Now the next thing is to fit these meters in, and so they just push fit into the back, cut the holes so that they are a sort of friction fit there. Just push those through like that. Now obviously they don't necessarily stay there. If you press on them they will fall out, so I'm going to put these in, and then we're just going to glue on the back here to secure them in position. Now we could in theory put screws through these holes, but then we'd have a load of screws on the front panel. So we're just going to put some glue onto the 4 corners there, and then that will just press down onto the back of there. I'm going to put them in so its voltage is on the left, so voltage there, and then current will be over on the right, and then the same underneath for the output as well. Now I'm going to glue in with this mitre bond. This is basically super glue, and comes in this bottle. There's also an activator as well, which will cause it to react far more quickly. So basically I'm going to put the glue onto the four corners here, so just put a little bit onto there, and then we'll put the activator on the back of the panel, and of course when the two meet up then it will be bonded permanently and forever. You can of course just use normal super glue, but the problem with that is it takes quite a while to set, whereas this stuff, say, is much quicker and generally far more robust. So I'll just do one of those, and then the activator we just spray on the back of here. Doesn't need a huge amount of it, just have to wet the surface, and then I'll just shove that in and repeat likewise on the other four. So next thing is just to put it onto the panel here. So I've glued those in with the super glue on the back, so then we don't have any screws showing on the front. Just looks a bit tidier. You can imagine if there's sort of 4 screws around each one, that's another 16 screws all going through the panel, so very untidy. Now these neons have to go in after, because the whole point of these is that we can use the screw on the back, or the nut on the back, to actually clamp onto the metal tab as well. So they go in afterwards, and those stay secure on the back with these 2 brass nuts here. So we'll just go on the underside. So I put those 2 nuts there. I'm going to leave those slightly loose for now, because we may need to adjust the exact position of the panel once we put the handles on. These just go on the front, and then the screws go in the back. Here are the screws. I've had to cut them down because they were supplied this long, absolutely ridiculous length, so to reduce the size. And I'm not entirely sure what this thread is. It doesn't appear to be a metric thread, it's something else, so otherwise I would have just bought some, got some shorter bolts from the cupboard. So anyway, we just need to put the screw through the back, and then it will come out on the front panel. And it's a question of attaching the handle on the front, and again this will clamp the actual front panel, the new one, onto the existing case, so then we don't have to actually bother with putting extra screws to hold it in position. So handles are on, and all screwed through on the back there. Fairly difficult to get down to those at the bottom, but nevertheless managed to get in there. I did have to actually take it off again and put it on, because I forgot that the panel on the steel actually overlaps where the nut goes, so it basically clamps on the steel as well. So just undid that and then put it through and put the nut back on, and the rest of it all in there. So just need to tighten up these brass nuts now that the rest of the panel is of course now locked in place by those. So I'll just tighten those up with a appropriate tool in a moment. And then it's a question of wiring. The socket, by the way, is actually wireable from the top. The screws are actually here on the top of the thing, and then the earth one is actually on the side, so it's still accessible even when it's actually in the case. And the wires themselves actually go in the sides here, so again not a problem in reaching those. And as you can see, the rest of them, it's just these 2 posts on the back of the meters. These have these sort of press-on 1/4 inch or whatever size connectors. The switch here just clips on the back, so you can wire that and then clip it on. And then the toggle switch, which will go through the hole there, that again has those same press-on style connectors on the back, so that will just go through there, and then we'll be able just to plug those on the back of that. Now this switch, in theory, it's supposed to have a sort of a cutout in the panel, so that this notch in the actual switch that's on the top there actually has a sort of corresponding tab on the panel, but the realities of cutting a round hole and leaving a little bit sticking down are pretty next to impossible. So what I've done instead, I've actually cut this hole so we can basically thread the switch into it, sort of like that. So it's not going to be sort of loose or anything there, it can actually, in there it's pretty secure. And then just going to also put the locking ring on the front, so hopefully when we get it in here we can also tighten it up to a reasonable degree, and then obviously we can Okay, put locking around the front, and that will secure it in place. This is actually a double pole, double throw switch, so it won't actually matter whether it's this way up, which is allegedly the correct way with the thing on the top, or whether it ends up being on the bottom, because of course it's just a question of different wiring on the back. Now for the internal wiring we're going to use this, which is 1.5 millimeters squared, or square millimeters, depending on how you want to pronounce that. It says square millimeters on here, and this is what's called tri-rated, which means it basically complies with 3 different standards, so you can use it in different countries, North America being one of them, and so on. And this is actually somewhat oversized for this thing, but I think it's better to go slightly larger than undersized. It's also rated to 90 degrees centigrade, so again fairly high temperature, because transformers by their nature do get hot when in use. So we're going to use this for pretty much all the internal wiring, and for the end of this we're either going to put the ring crimped on for appropriate onto things like the posts there for the meters, or we're going to put the actual pins on where it has to actually go inside terminals, and of course for things like the press-on connectors, well of course going to be fitting those on here as well. So quite a lot of crimping involved here, and this is a stranded wire, so people get busted up over crimping solid cores don't need to panic, because no solid core used here. And for the mains input, which will obviously go in the back where the hole is, and just see that over the back there. Then we're going to be using this. This is flex, it's 3-core, also with the earth connection and the line in neutral. This is also 1.5 square millimeters, or millimeters squared, and this is also heat resisting as well, so all sort of fits together the same plan. There's quite a lot of length here, I don't know whether we use all of it, but nevertheless that's what we're going to use. And then we have our white plug, which of course will go on the end like that. This is an MK one, it's a Dura plug, apparently now made in Malaysia, not made in the UK as they used to be, but I presume it's made to the same standard, so shouldn't really make any difference. Now for the end of the wire we're going to need some of these. These are pin terminals or ferrules, and basically they will just go over the wire there, crimped down, that we don't have any stray strands of wire flapping out. That's obviously a bit long there, just to strip that for a random length. And then for the others, got these rings here, and again these just crimp onto the end of the wire. Again that's far too long, obviously it will be crimped on the end like that. And for the other things with the press-on connectors, then it's these things, and again they'll just crimp on the end as well. So various different styles of connectors there. One thing of course is, do these in fact fit on the back of here? Let's hope they do. Well, unfortunately they seem to fit perfectly, so no problem with that. And I've already tried this on the transformer, which is over here. They do fit on that as well, so no problem with those. So now it just remains to get all this wiring and gubbins together and get the whole of this wired up, and then we should just end up with the wires from this coming up to the transformer, and then we can put the transformer in and get it sorted. Now just get this plug wired up onto this 3-core flex, say 1.5 being the size, and what we'll do is just score around the actual flex here, so we don't go right through, and then we should be able to actually break the flex there, so it will basically tear apart along the actual break line. So there's the 3 inner cores there, they're covered in this dusty chalk-like material. And the plug here, say this is an MK one, or it's a actually Dura plug branded, but basically the same deal. And unlike plugs of old, it has this wraparound piece here, but it doesn't go all the way over, because of course in the past they were the ones where if you wired the top then you found you couldn't actually put the lid over. Bit of a fail, but they've at least avoided that on the new design. So just place the flex in there, and then we just mark off the appropriate lengths for all the 3 conductors. Trim those down to size. And the point of these, you want to make sure that the flex actually goes underneath the grip here, and it's gripping onto the white part. And then of course you've still got enough for the actual wire to go into the terminal. Neutral will of course come around over here. And then the earth one, which being the green and yellow, we want to make it as long as we can. The idea being if this was pulled out of the plug at a later time, then these would pull out first and it would keep the earth connected as long as possible. So we want to sort of push that over to the left there, and we'll cut that at that position there. And again, we need to strip these. You can put little ferrules on the end of these, but we're not going to because it's actually quite difficult to get them in here. There's very limited space inside plugs anyhow, and they're generally designed so that there aren't actually any loose strands going to get anywhere, because these are all obviously enclosed in their own little plastic enclosures anyhow, but you can put them on if you really want to. So in this case we're not going to be doing that. So here's the plug after wiring. So neutral on the left, line over on the right where the fuse goes, earth on the top, and we've got the insulation going right up to the terminals, so there's no sort of bare copper showing on that side, and of course the screws clamp down onto the bare copper within the terminal, and the flex grip is gripping onto the outer white covering, not the inner coloured conductors, and it's gripped there, but it's not sort of graunched down to the maximum, because otherwise that would damage the cable. So only other thing then is just put on the lid, so just press it over, and then there's a single screw in the back to secure that in position. And again, we're tightening this up to hold it on. It is not necessary to turn it down with 10 tons of force, because it's there to hold the lid on. It does not need torquing down to the absolute max. So that's that end finished, and so this is a decent one with proper brass pins, not those awful shiny silver ones made out of plastic with the look of real metal. So I just stripped off a moderate length on there, and we'll just shove that through the fitting like that. Now we're going to want this to go along the side of the transformer like so, and then we're going to want it to go to the front somewhere here, so that should give us enough length. Some of those are going to go to the switch over there. We're going to need to put some additional connectors in somewhere as well, but that should be a reasonable length. So if you bring it up to the front, then what we're going to do is put these cable ties around the flex. I'm going to put those up at the end here. I'm going to put another one on the basically the other way up. So yes, that'll be that way around. Now that one we're going to tighten as much as possible and then cut off, and the other one we're going to put just against that on the same piece of cable there, but sort of opposite. Tighten that up as well, and we'll cut that off as well like that. Now the reason for these is these will grip on the cable and stop it pulling through, so see that will stop it going through there. Because this thing on its own is just a rubber seal, and that will grip on the cable. They don't grip all that well, so in theory if you pull this, or over time it could gradually creep out of the equipment, but with these things they'll prevent that from going through. So it's generally a much better idea just to have that on the inside, and then this will just seal down to obviously prevent dust and whatever getting in. So we'll just tighten that down to a reasonable extent like that. I've already tightened on the fitting, so that's now secured in there. So there's our lead on the end, so we've got a couple of metres of length on the end of that. Now I've completed all of the wiring on the inside and also put all the stuff in the panel. So here is the front panel. Here is the selector switch for the 4 tappings from the transformer. Power on off switch, socket here, and then we've just got the neon indicators, and this will be the voltage in and the current in and the voltage out and the current out. And of course the voltage out will depend on what tapping is selected, and of course the current then will be proportional on each. And on the inside, as well as the white mains lead coming in there, which we saw earlier, I've got all the rest of the stuff. So here's the back of the panel. So we have the mains lead coming in here on the white, and the switch down here is to fit on and off. We're only using a single pole, it's just switching in the line only. It is a double pole, but for reasons we're not switching the neutral. And power comes in onto the meter here. This is the voltmeter, and that goes straight in onto this here from the incoming supply. And then we have various other lines going off. two other areas there, and again the neutral also comes in onto this meter as well, and this top neon is wired to these also, so that basically when you plug it in, power is applied, this meter will show the voltage and this indicator will illuminate regardless of the position of the switch. Now with the switch off, that's pretty much all that happens, but when this switch is on, so you've got power coming down to the switch and then coming back over here, then that will obviously power things over here, and this will obviously go through the amp meter here, so that will just basically go straight through. And from this one, we've got a lead going across here to the other neon indicator, so with the switch on we'll have both the neons illuminated, and then we've also got the wire coming off here, and this is what will go to the transformer, which we're going to install in a moment. And we've got one from the meter here, which is the line, and we've also got the neutral, which goes across to one of the neutrals over there. So with the switch on, this is basically going to be lining neutral in from the supply. Neutrals on both of these are common together on both of the voltmeters, because of course they're just a neutral connection there. We're using it as a terminal block for the other neutral items. The other side of this, which is the outgoing supply, is here, and that actually goes across over here to the outgoing ammeter, and the switch here is what does the selection of the tapping. So these two basically go to transform as the line and neutral supply, and then these four, which I put little numbers on here so we know what we're doing, are the four tappings we're going to select from the transformer, and that will basically give us our four different voltages. One of these will be connected, depending on, of course, the position of the switch on the front. Output from the switch is over here on the side, and that just goes around here into this ammeter here. And then, of course, the current will flow through the ammeter and therefore display whatever the output current is. And the other side of that just goes to the socket. And the other one here, which actually goes across, just goes over to the voltmeter. And again, that would mean we can just display the voltage on the output. Now, the reason I've done it in this slightly odd arrangement is that I wanted to have an indicator to show that power is connected to the thing, which is this one, and that's not switched, and the other one to show that when the power is actually turned on, effectively showing that the output was on. We can't actually put this neon on the output of the transformer because, bearing in mind, this is going to give a significantly higher voltage depending on where it's connected on the output. So of course, if it's set to a 400 volt output, we can't put 400 volts in a 200 volt neon because it's going to blow up. So basically this is switched on the input side, but it only turns on when the switch is on, which means the transformer then is powered, and of course the power will be coming back the other way. That's also why I'm not switching the neutral, because if we switch the neutral, of course we wouldn't have a neutral to any of the actual neons anyway, so of course they wouldn't work. And we could do a kind of weird thing where we sort of switch half the neutral to the transformer, not to the neons, but that's a bit rubbish anyway, so that's not how it's done. So the switch will turn on and off basically the transformer and the output, but single pole only, and it's really there just for a convenience item. It's not intended for isolation purposes, because of course if you want to isolate the thing on the output, just simply unplug it. Of course that's going to be far safer than relying on any kind of switch. So all that's remaining now is to attach these wires here to the transformer, which of course sits in the middle in here. So it's basically the power in, and then one of the four actual tapping outputs. And the transformer actually bolts down into the bottom here, and on this one I've scratched away some of the paint. So the transformer foot will basically make contact with the metal case here. And I've also removed some of the varnish on the transformer leg there as well. Now in terms of fitting the transformer, it just sits over these holes inside. And how this is going to work, we're going to put these rubber feet on the bottom. These have a metal insert inside, and they're actually made by Penn Elcom, and they're actually made in the UK, not China. And these are M6 threaded, or well, it's M6 clearance holes. So this M6 screw here will go in, and then you see it's flush on the bottom. That goes underneath, pokes through, and then the transformer will go on top of these, and then we'll just put the nut on the top to secure it in position. And we are going to put a washer on the top here. The nuts we're using will be these nylock ones with the thread and the blue piece of plastic in the top, so they'll tighten down without coming loose. And over that corner where I've removed the paint, we're just going to put one of these in, which is one of these sort of star type washers with the pointy bits on the outside. That will just go between the case and the bottom of the transformer, just to make sure we've got a good contact between the two, as we're going to use that as the earthing point for the case. So that's the wiring inside complete. So we've got the neutral connected here with mate L1 there, And then the other wire on this one is the supply, so we're going to put that in here where it's marked 230. And then we have the 4 outputs, which are marked 1, 2, 3 and 4 here. So basically 2 of them will give us a lower voltage there, and then 2 of them a higher one. So it's basically 200, 215, 245 and 260, and those are the ones that are controlled by the switch on the front panel. Additionally, I'll put a fixing here. So basically this wire is what goes over to the lid, so the earth for the top piece, and then the other one here goes down to the earth connection on the socket, and the earth from the mains lead coming in actually goes to the socket as well. So it's basically coming in to the socket, this goes up to the piece here, which again goes through the actual frame and everything else, and then the one goes over the lid as well, and the transformer itself of course is bolted down to the bottom to make sure that the bottom half is earthed as well. So there is the finished item. The plug here, there is a relatively close to the bottom, but we've got the space here and also the gap where the feet go, so it does actually fit there perfectly well, so not a problem. Not really anywhere else you could put the socket other than on the top or the side or something, because obviously there's only so much room on the front panel, but all fits there okay. So basically it's on and off here, and then your 4 voltage selections over there, and then it's voltage and current in and voltage and current out, and then of course the 2 will light up depending on whether it's on or off. So here it is in the on condition, and we can see the 2 voltages marked there, obviously the input and the output. In this case we're on the bottom one, which is basically reducing the voltage to basically about 212 on the output. This is just connected to this blue lead here, and we can see there that the voltage going in is the usual sort of 245 or whatever it is normally here, and the output of course is slightly lower there. Current of course is 0 because there's not actually any load attached other than this meter, but if we plugged a moderate load in of course that would show there. And if we change up to the next one, see now we've got 228 coming out there, and again if we move up to the next one, that gives us around 259, or well 260 nearly, and then if we turn to the top one, then we get about 275 or just under, and again the meters obviously show the general indication of that. So that's pretty much complete now, and so this switch here is basically the power on and off. So the power off, we've still got the input power there of course because still connected to the supply, but the output of course is off, and also it doesn't actually show the voltage there as it's not connected. So that's the transformer completed, and so we've got it set there so it can have 4 choices. In this case it's 2 lower and 2 higher, but obviously there's other tappings in there so we could simply move those around as needed whenever. So whatever you've got you can choose from any 4 of the output voltages that it has. And so in this case, say it actually goes up to about 275, even though that top one is marked 260, because of course we're feeding it in on the 230 tapping, and so the voltage in the UK is generally around 240 or so, despite the fact it's supposed to be 230, but it doesn't particularly matter, it still works just fine. So that's it for this time. We'll be seeing it of course again in no doubt in future videos, but until then, thanks for watching.